morning, guys. So what we're going to be working with, we're going to be continuing with similarity, right? And specifically with that, we're going to be working again with dilations. Now in the past we've spoken about dilations, but we never gone into it in regards to an aspect of scale factors or how it compares to similarity, right? So before anything else, just remember, whenever figures are similar, it means that they're alike, right? It's going to be the same figure but different sizes. Whereas if two figures were congruent, it means that they would be same everything, same size, same shape, same measurements, right? So we're going to look at dilations through the eyes of similarity, right? And so when you have a dilation, again, you know that it's a transformation where the size is actually changing, right? It's either getting bigger or it's going to get smaller. And exactly the explanation of similar figures, right? Because if we have a triangle, right? We're going to have one that's big, one that's smaller, right? But going back to all of this, and again, we would know that these are similar after we would actually analyze angle measurements and side measurements because, again, angles would be congruent, sides would be proportional, right? The size is changing, but it's changing equally, right? It's changing proportionally. So we're looking at this, and now we're going to analyze dilations, right? Again, dilations just means that the size is changing, either getting bigger or smaller. But we don't know which one is happening, right? Because we look at this, some people would say it clearly got smaller because the one that's on the right is smaller. Some people would say we can't tell. And in this case, we can't tell because in order for us to know whether the dilation got bigger or smaller, or reduction or enlargement, we need to know what came first and what came last. And then again, this should be some review, whereas you have A, and then we have this called A prime, right? And whenever you have the prime comes last, right? The one without the prime comes first. We know that the one with the prime, we call that an image, right? Because the image comes last. We know that the one that comes first is called the pre-image. And the pre-image always comes first, right? So first question that you always have, whenever people are asking you all this, whether it was a reduction or enlargement. Again, enlargement means that it got bigger. Reduction means that it got smaller. So if I'm looking at this case and I wanted to know whether it was a reduction or enlargement, we know that this is a reduction, right? And the reason why we know that this is a reduction is because we see the prime comes last. The last one is small. So if it's small, it's a reduction. Because this was the first one, the pre-image, it was big and then it became small. So if it went from big to small, it became a reduction, right? If it was the prime here, we would know that it was an enlargement because it got bigger, right? So this is how we actually analyze whether it's a reduction or enlargement, by seeing what's happening and seeing which one comes first, which one comes last, right? So always keep that in mind, the primes. The prime is always the most important thing. And with that, right? Knowing the primes, knowing whether it's a reduction or an enlargement, we now are going to focus on scale factors just for a second. Because when it comes to dilations, we need to know whether it was a reduction or enlargement, and we need to be able to analyze the scale factors as well, right? So when we're looking at dilations, right? So we have dilations and scale factors. And again, with scale factors, we worked with them when we were analyzing similar figures because it was able to tell us information about how much it was actually changing or whether it was changing proportion, right? Scale factor also tells us a lot more. Scale factor also tells us how much bigger something is getting, how much smaller something is getting, what we reviewed. So again, if you had a scale factor of 2, it means it gets 2 times bigger. If you have a scale factor of 1/2, it means it gets 2 times smaller, right? It's half the size. But there's always a consistent relationship based on scale factors. So like what I mean is, if I were to look at the scale factor of 1.87, let's say I looked at the scale factor of 0.93, let's say I looked at one that was 0.76, I looked at another one that was, let's say that I looked at one now that it was 2.6, another one that's 5, another one that's 0.12. We have those 6 scale factors, right? And from those 6 scale factors, 3 of them show that the figure got bigger, it was an enlargement. 3 represent that the figure became smaller, it was a reduction. And some of you may be able to tell easily, the ones that show that it became an enlargement, right, and I'll write it in blue, right, so blue will be for enlargement. Right? The ones that represent enlargement is the 5, the 1.87, and the 2.6. Those represent the enlargements, right? Okay. Some of you may already notice it, some of you may not yet, which is okay. To figure out which ones are the reductions, I'll analyze the reduction in green, right? I know that this is going to be a reduction, I know that that's a reduction, and I know that that's a reduction. And again, some of you may actually be able to see already why it is, some of you may not. So we know that the enlargements are in blue, right? 1.87, 5, 2.6. We know that the reductions are in green, the 0.12, the 0.93, 0.76. The relationship that always exists with scale factors, if the scale factor is bigger than 1, if it's automatically bigger than 1, so 1.87 is greater than 1, greater than 1, greater than 1. If it's greater than 1, it's an enlargement, automatically, and I'll write that then. If, notice these, people always assume that for a reduction, automatically it's less than 1. It's not. For it to be a reduction, it has to be between 2 numbers. It has to fall between 0 and 1. If it's between 0 and 1, it's a reduction. If the scale factor is greater than 1, it's an enlargement. So if we look at these 3 in green, these are all between. That's between 0 and 1, that's between 0 and 1, that's between 0 and 1. That's why it's a reduction. This is greater than 1, greater than 1, greater than 1. That's why it's an enlargement. And that's the one rule that we have to actually learn when it comes to scale factors, just without having an illustration, because people become so dependent on the illustrations that they forget sometimes that these things are much easier to analyze, very easy to analyze. So if we're looking at an enlargement, right? If we have an enlargement, it's exactly what we saw, right? An enlargement, scale factor is greater than 1, always, is greater than 1. If we have a reduction, again, if we have a reduction, which just means that it gets smaller, if it's a reduction, the scale factor is going to be between 0 and 1. Scale factor is between 0 and 1, always. And again, it's important to be able to actually analyze that, because when we don't have an illustration, the scale factors tell us everything we need to know, right? And then we're going to get to work right now on calculating scale factors in a second, but I do want you guys to see that. So if it's greater than 1, it's an enlargement. If it's between 0 and 1, it's a reduction. If it's exactly 1, it doesn't change size. Because just think of it this way, if I had the number, let's say I had the number 5. If I do 5 times 1, it stays at 5, right? It doesn't change. So whenever you have a scale factor of 1, whenever you multiply it by 1, it doesn't change. So if you see 1, it doesn't change, stays the same. If it's between 0 and 1, it's a reduction. If it's greater than 1, it gets bigger, right? So now let's look at how we can actually analyze scale factors and calculate scale factors, right? So we were able to see what happens when we have certain types of scale factors, but now let's see how to actually calculate them when we have illustrations, right? So again, I'm going to go back to that example with the triangle, but I'm going to draw it a little differently. Okay? And I will do 2 of these just for you guys to see. Let's say I had this, right? I have that. One triangle is inside the other one. And again, hopefully you guys are telling yourselves which one came first, asking which one came first. Right now, we can't tell, because again, the way that we're always able to tell is by having the prime, right? So let's say that the one inside, the smaller one, is A. Let's call the one on the outside 8 prime, right? So before we do anything, we already know this is an enlargement, right? And we know it's an enlargement because again, the prime is on the outside, prime's on the big one, so it got bigger, right? Because the prime always comes last, the image. We want to actually now calculate scale factors, right? So let's say that we had this. Let's say that this here is going to be 8, right? And let's say that the side here on the bottom is going to be 12. The good thing is you guys are really good with calculating scale factors, right? We always have to divide to calculate scale factors, but some people are going to look at this and say, wait a minute. Some people are going to say to find the scale factor, I can do 8 divided by 12. Some people are going to say, I'm going to do 12 divided by 8. And here's the issue. One of those is correct. Only one of them. You have to divide in a certain order, because if we look at this, right, 8 divided by 12 is going to give us 0.67. If we do 12 divided by 8, it's going to give us 1.5, right? And this is what I'm trying to get you guys to understand. The scale factors do matter. So scale factor 0.67, scale factor 1.5. And some of you already may be able to see this and see. We said it's an enlargement. 0.67 is getting smaller. 1.5 means it's getting bigger. So it would be this. This would be our answer, right? This would be wrong because 0.67 means it's getting smaller. 1.5 means it's getting bigger, an enlargement. We said it's getting bigger. But how do we always know which one to do without having to do both, right? The way that we always know is we always start with the prime. Whatever the prime is, that's the first number that we start off with. That's what's going to be in our numerator. So our prime was 12, so we start with the 12. So it would be 12 divided by 8. And that's always going to work, guys, always. Always put your prime, always put the image as your numerator, right? Always start with that. So if you don't want to have to go through all that work, always just realize if I want to calculate my scale factor, start with the prime. Prime is 12. So we would just do scale factor equals 12 divided by 8, which automatically gives us 1.5. Here's our answer. We don't have to think about any of it. It's just automatic. So always start with the prime. Don't always start with the biggest term. Always start with the prime. If the prime is a small number, start with the small number. If the prime is the big, start with the big, right? But let's do another one of these just to make sure that you guys actually get the hang of it. Because then the last thing I have to show you, it's actually pretty simple, guys. Nothing too difficult about it. Let's say now that I gave you 2 circles, right? I'll give you this larger circle. I'll give you this smaller circle, right? I'm going to give you this here. Let's make that there. Let's make this here, right? So first thing I'm going to do, I'm going to call this A prime. I'm going to stop calling it A. I'm sorry. So when you try to make things better, it looks worse sometimes. Let's call this F, and I'm sorry about that, F prime, right? So F prime is right there. Now let's call this one here F, right? So again, before we even start with anything, we see that the F is on the outside. We see F prime is on the smaller one, right? So automatically, since the F prime is on the smaller one, and the F is on the bigger one, the F prime is on the smaller one, means it was a reduction, right? Got smaller. So we already know without anything, it's a reduction, right? And it's a reduction because the prime is on the smaller one, right? So now we want to figure out scale factors, but let me give you values, right? Let's say that this here is 3. Let's say, so from here to there is 3. Let's say that this one is going to be 6. Okay? I want to find the scale factor. So remember again, to find the scale factor without any thinking, always start with the prime. Our prime is here. That's the 3. So we're going to do 3 divided by 6. Right? Always start with the prime value. So the prime here, that would be 3. So we do 3 divided by 6. 3 divided by 6 is 0.5. 0.5. That's our scale factor. And that would be it. And we know our scale factor is right because again, 0.5 is between 0 and 1. 0 and 1 means it got smaller. Reduction. All it is, guys. Okay, that's how you calculate scale factors. That's how you analyze scale factors. Now, the last thing I want to show you is how to actually be able to calculate coordinates, which is extremely simple. It is something we've already done before, but I did just want to remind you guys of this. Let's say that we had a coordinate, right? Let's say that we had the coordinate of G. Now let's say G was -4, 7, right? And I tell you that it has a scale factor is going to equal 3, let's say. I want to find the value of g prime. Okay? I want to find the image. I want to know what g prime is going to be. Right? So in order to find g prime, scale factor means it's getting, since it's 3, it's getting bigger. It's bigger than 1. All we ever have to do is just multiply, right? So since scale factor is 3, we're going to take the x, we're going to take the y, multiplying by 3, right? So we're going to do -4 times 3, which would be -12, right? Because we did -4 times 3. And then we're going to do 7 times 3. 7 times 3 gives us 21. That's it. That's all it would be, guys. Whenever you want to calculate the images, you just multiply it by the scale factor, right? So -4 times 3 was -12. 7 times 3, 21, right? Just want to do one more to show you a reduction. Make sure that you guys are comfortable with it, right? And again, sometimes it's just making sure that you guys can work with it. Let's say that we had the coordinate of, let's call this h. Let's say that this is going to end up being 12, 18, right? And I'm going to tell you that the scale factor, is going to end up being 1/3, a third. Again, I want to find h prime. So since it's 1/3, 1/3, we know that now it's a reduction. It's getting smaller, right? And again, I always tell you guys just to make sure that you feel comfortable with this. So we're going to be doing 1/3 of 12. We're going to be doing 1/3 of 18, right? So we would do 12 times 1/3, right? And if you feel comfortable with this, you can multiply the fractions, right? Always remember, change the 12 to 12/1. 12 times 1, always go across. 12 times 1 is 12. 1 times 3 is 3. We know that 12 divided by 3 is 4. Right? That's one way to do it. You could also say, what's 1/3 of 12? Think of it that way. 1/3 of 12 is 4. You can look at it as whenever it's 1/anything, you divide by the denominator. 12 divided by 3 was 4, right? If you even want to change it to a decimal, you could. 1/3 would be 0.66666, repeating, times 12 would give us 4, right? Look at it that way, however you want. But easiest way for most of you is probably going to be whenever you see 1/anything, you would just divide it by the denominator. So 12 divided by 3, 4, right? Now, let's take care of the 18, right? We have 18 times 1/3. Same thing, put it over 1. We have 18 times 1 is 18. We have 1 times 3 is 3. 18 divided by 3 gives us 6, right? There's our y value. And again, if you want to think about it, 1/3 of 18 is 6, right? 18 divided by 3, 6, right? 0.66666 times 18 would give us 6. And there's our answer, guys. Just want to show you some practice with fractions. But remember, scale factor of 1/3, we knew from the beginning it was going to get smaller. And notice how the coordinates did get smaller, guys. So always remember, if the scale factor is greater than 1, it's an enlargement. If it's less than 1, if it's between 0 and 1, it's a reduction. And if it's exactly 1, stays the same. And remember, the prime is what tells us whether it became a reduction or an enlargement. Any questions, feel free to ask, guys. Take care.